Ever looked at an exam question and wondered what the person marking it is really looking for? Well, today we're going to find out. We are going to deconstruct a real GCSE physics question piece by piece so you know exactly how to secure every single mark. Let's get inside the examiner's head.
Because, look, getting top marks isn't just about knowing the answer. It's about communicating that knowledge in the exact way the exam wants you to. It's all about proving you really get the physics behind the question.
Okay, let's get specific. We're diving into question 4 from the AQA GCSE Physics paper all the way from June 2022. Our focus, the physics of a single falling hailstone. Sounds simple, right? Let's see.
So, the first part of the question takes us right back to the fundamentals. It's all about that classic relationship between forces and acceleration.
Okay, first up, a nice, easy one-marker to get us started. Why does a hailstone accelerate when it starts to fall? Before I show you the answer, just take a second. What would you write down?
Right. Let's check out the official mark scheme. And what's interesting here is there are actually 3 different answers that would have gotten you the point. You could have said there is a resultant force acting. Simple. Or you could have been more specific and said weight or gravity is greater than air resistance. That works too. Or you could describe that very first moment, saying weight or gravity is the only force acting. The key is any one of these gets you the mark.
So, the hailstone starts accelerating. But it can't just keep getting faster forever, can it? Of course not. And that leads us perfectly into the next concept, terminal velocity.
Now, for a bigger question, this one's worth 3 marks. You have to explain how the hailstone reaches a constant terminal velocity. And that word, explain, that is a huge clue. It tells you they're not looking for a single fact. They want a logical sequence, a step-by-step story of the physics.
And here is the perfect 3-step structure for your answer. First mark, you state the relationship. As the hailstone gets faster, air resistance increases. Got it? Second mark, you describe the tipping point. Eventually, that upward push of air resistance becomes equal to the downward pull of the hailstone's weight. They're balanced. And that gets you the third and final mark. You state the conclusion. The forces are balanced, so the resultant force is 0. And what does 0 resultant force mean? 0 acceleration. It stops getting faster, it's hit terminal velocity. Boom, 3 marks. And hey, here's a little pro tip, taken directly from the examiner's own notes. In this specific answer, they'll let you use the word speed instead of velocity. It's a nice little reminder that they're testing your understanding of the physics, not just trying to catch you on a technicality.
Okay, let's build on that. The next question is for 1 mark, and it asks, why does terminal velocity increase with mass? So why does a heavier hailstone fall faster in the end? For just 1 mark, you know the answer needs to be short, sweet, and to the point.
And there it is, the single point you need to make. A larger mass means a greater weight. That's it. Think about it. If the downward force of weight is bigger, the hailstone has to fall much, much faster to build up enough upward air resistance to balance it out. Simple as that.
Okay, the question is about to shift gears. We've talked all about forces and velocity, so where do we go next? You guessed it, we're now going to look at the energy of that moving hailstone, specifically its kinetic energy.
Now this is a tough one. It's a 3-mark question that really weaves a few different ideas together. The question asks you to explain why, if you double a hailstone's mass, its kinetic energy more than doubles. This is where you really have to show your stuff.
So let's trace the logic the examiner is looking for. First mark, you just state the basics. Kinetic energy depends on both mass and velocity. Easy. Second mark, you connect back to what we just discussed. A bigger mass means a higher terminal velocity. Okay, now for the crucial third point, the real key to the whole question. The kinetic energy formula has mass in it, but it has velocity times squared. So when you double the mass, you're not just doubling that m in the equation, you are also increasing the velocity. And because that velocity value is squared, its effect is magnified, which is why the total kinetic energy goes up by more than double.
This table sums it up perfectly. You double the mass, that makes the terminal velocity increase. And because both of those factors go into the kinetic energy equation, with velocity being squared, the final result is that the kinetic energy more than doubles. It's a compound effect.
All right, time for a quick-fire round. A simple question on fundamental units. For 1 mark, what is 1 joule equivalent to if you use the standard units for force and distance?
And the answer is 1 Newton meter. Remember, a joule is just the amount of work done when you apply a force of 1 Newton over a distance of 1 meter.
That is a nice, straightforward mark just for knowing your definitions.
Okay, we are in the home stretch now. We've reached the final part of the question, and this is where it all comes together in a calculation.
So, for the final 3 marks, you have to calculate the impact force of the hailstone. The exam paper gives you all the numbers you need: the mass, the velocity, and the impact time. So, how do we use them to get the marks?
Let's walk through it. Your first mark is for correctly identifying the mass from the data they gave you, which is 0.0185 kilograms. The second mark comes from substituting that and the other numbers into the right equation. That's force equals the changing momentum over time. And finally, the third mark is for getting the calculation right, which gives you a final answer of 7.708 newtons.
And here is one last absolutely crucial tip, again, straight from the mark scheme. The examiners also accepted an answer of 7.7 newtons. This is such an important lesson about rounding. You always want to give your answer to an appropriate number of significant figures. It's such an easy mark to lose right at the very end if you're not careful.
So, what's the big takeaway from all this? Well, getting the best marks isn't just about knowing the physics. It's about understanding the logic, it's about structuring your answers with real precision, and it's about knowing exactly what that examiner wants to see on the page. The real secret, then, is learning how to prove you know it.